Find the arc length of the graph of y equals x squared on x equals 1 to x equals 3. So we're talking about this arc length right here from x equals 1 to x equals 3. So we're talking about that amount of arc length, and it's not straight, so there's some complexity to it. So what we do is we choose some representative x value, say here, go up to this curve and make a little right triangle picture like a slope. Then we come over to here and blow that up. Here's our representative x value. We have our delta x and our delta y, and the straight line segment joining the points there is the square root of delta x squared plus delta y squared. But it turns out, as we know, that f prime of x is approximately delta y over delta x. So delta y is approximately f prime of x delta x. So the segment length joining the 2 points, the straight line, is this square root. But now we realize that the delta y is approximately equal to this, so we put it in there, and that's right here. And then we factor out a delta x squared, and then the square root of delta x squared is delta x, so we just have this statement here. So the arc length is going to be the sum of all those segments as we move x values from 1 to 3. So you have the sum, and it sets up an integral very nicely. The arc length is going to be from x equal to 1 to 3 of this quantity dx. So then to finish that up, our function we're dealing with is x squared. F prime of x is 2x. So we put that into the formula there, right here. And we get this integral here. 1 to 3 of square root of 1 plus 4x squared. Now, in Calculus 1, we did not learn the methods for finding that integral, so we're just going to run the program with trapezoid reporting out n equals 100. Comes out to be 8.268. Now, just to check to see if that's in the ballpark, the straight line segment joining the 2 points had this distance, delta x squared plus delta y squared, over the entire range there, and it came out to be 8.246, which is under, which it should be, because the arc is curved between the 2 points and the straight line segment is straight, so the straight line should have a less length than the arc, which it did. And it's in the same general ballpark of value, so it seems to be checking out.